Imagine discovering that the universe we live in is vaster and more amazing than we ever imagined. This is exactly the mystery that shook astronomy to its core and revolutionized our understanding of the cosmos 100 years ago. Today, I'm going to tell you the thrilling story of how, amid heated debate and groundbreaking observations, science revealed that our Milky Way was not the entire universe, but just a tiny island in a sea of galaxies. Stay with me as I reveal fascinating details, historical trivia, and behind-the-scenes stories about a discovery that forever changed our view of space. On November 23, 1924, as readers of the New York Times flipped through page 6 of fur coat ads, a bold headline announced, "Spiral nebulas found are stellar systems." This news, which highlighted the discovery by astronomer Edwin Powell Hubble, whose last name was even misspelled, shocked the world, as it demonstrated that these brilliant structures, until then considered part of our galaxy, were in fact independent universes, just like our cosmic home. The revelation that spiral nebulae, such as Andromeda and Messier 33, were located outside the Milky Way was a game-changer. Imagine the surprise of scientists when they discovered that the universe was not a limited and closed space, but rather a landscape filled with trillions of galaxies, each with its own stars, planets, and mysteries. This breakthrough not only expanded our perception of the cosmos, but also provoked a paradigm shift in astronomy, challenging old theories and paving the way for new explorations. 4 years before this revolutionary announcement, one of the most iconic debates in the history of astronomy took place in Washington, D.C., known as the Great Debate. On one side, Harlow Shapley, who defended a gigantic Milky Way, capable of harboring all the spiral nebulae, and on the other, Heber Curtis, who categorically stated that there were other star systems besides our own. Although Curtis was the most convincing voice for many at the time, it was precisely the method of measuring distances developed by Shapley, inspired by fundamental discoveries of a pioneer in science, that paved the way for Hubble's confirmation. This pioneer was Henrietta Swan Leavitt, a brilliant young woman who, at the Harvard College Observatory, immersed herself in the study of variable stars in the Small Magellanic Cloud. By analyzing more than 1,000 stars, Leavitt discovered that Cepheids, stars that pulsated, showed a direct relationship between the pulsation period and their intrinsic luminosity. In other words, the slower the star pulsed, the brighter it was. This period luminosity relationship was a game-changer, allowing astronomers to turn these pulsations into a precise tool for measuring cosmic distances, putting their feet firmly on the trail of discovery. The technological landscape of the time also played a crucial role in this journey of discovery. At the Mount Wilson Observatory on the outskirts of Los Angeles, the Hooker telescope, with its 2.5-meter mirror, the largest at the time, made it possible to capture images of astonishing sharpness, essential for identifying Cepheids in distant galaxies. With this powerful tool, Hubble was able to compare his observations with those recorded previously and notice something extraordinary. The distance of the observed Cepheids was much greater than previously thought, showing that these nebulae were, in fact, stellar systems located far beyond our Milky Way. But the discovery did not stop there. By combining the precise distance measurements obtained through the period luminosity relationship with analyses of the Doppler effect, which indicates whether an object is moving away from or approaching us, Hubble added to the observations made by Vesto Slipher, who had already noticed that the nebulae exhibited a redshift. This set of data culminated in the formulation of Hubble's famous law, which shows that the further away a galaxy is, the faster it moves away, suggesting that the universe is constantly expanding. This finding is the basis of the Big Bang model, the theory that explains the origin and evolution of our cosmos, and which transformed our understanding of time and space. Looking back and analyzing this incredible scientific trajectory, It is impossible not to marvel at the courage of the pioneers of astronomy who, challenging the paradigms of their time, dared to question what was considered certain. Hubble's discovery was not the result of an isolated moment, but rather of a series of advances that, together, formed a mosaic of knowledge, showing that the universe is much vaster and more dynamic than we could have imagined. Each step, from the meticulous analysis of photographic plates to the use of powerful telescopes, was fundamental to revealing a secret that until then had been hidden from our view. However, one of the most remarkable aspects of this story is that Edwin Hubble's discovery not only changed our understanding of the cosmos, but also redefined the very way we view our place in the universe. Before his revelation, scientists believed that the Milky Way was the center of everything, and that the entire vast expanse of stars could fit within it. This mindset was a reflection of human thinking throughout history, where we have always tried to place ourselves at the center of existence. However, the confirmation that countless other galaxies existed dissolved any illusion of centrality and ushered in a new era of questioning. If there are so many galaxies out there, each with billions of stars and countless planets, are we really alone? This question, once a philosophical one, has become a real scientific one, and astronomers have been searching for answers ever since. What's more, technology has advanced exponentially since the days of the Hooker telescope, allowing us to see the universe with greater clarity than ever before. Space telescopes like Hubble and the more recent James Webb have captured images of galaxies so far away that their light went out before Earth even existed. We are literally peering into the past of the universe, as if we could watch its history being written in real time. These new observations have not only confirmed the cosmic expansion predicted by Hubble, but also provided surprising evidence about dark matter, dark energy, and the possibility that our universe may be just one of many. 100 years ago, Hubble proved that the Milky Way was not the only home to stars. And now, we are on the verge of new discoveries that could reveal that our own universe may not be the only one. What else awaits us in the depths of space? The answer, as always, lies beyond our imagination. Today, the story of how we discovered that the Milky Way is just one of trillions of galaxies is inspiring scientists and curious people around the world. This historic milestone teaches us that, even when faced with apparently consolidated theories, the search for truth requires courage, innovation, and, above all, an open mind to new possibilities. The lessons left by Hubble, Leavitt, Shapley, Curtis, and so many others continue to drive science and remind us that knowledge is infinite, just like the universe we inhabit. They are real examples of how persistence and passion for discovery can transform our reality. So, did you enjoy this journey through the history of astronomy? If you were as fascinated as I was by these decisive moments that changed our view of the cosmos, be sure to like the video, subscribe to the channel, and share this knowledge with your friends. After all, each new discovery shows us that, even after a century, the universe is still full of surprises waiting to be revealed. And we are here to explore each one of them together.